Okay, today we're going to be talking about triple integrals using spherical coordinates. This video may look a little different than all my other lecture videos because I had a technical issue with my camera in my last class, so I'm sitting here doing this video without a classroom full of students. It's just me, so if it appears that I'm not talking to the class, that's what's going on. Okay, so spherical coordinates. We already know that when we're looking at triple integrals, we are usually trying to do a triple integral over some region, let's say E, of some function of x, y, and z with respect to volume. And we've seen there is one way we can do these without using Cartesian coordinates, and that's to convert this to what we call cylindrical coordinates. And in that, what we do is we replace x, or we substitute x as r cosine theta, we let y be r sine theta, and we let z just remain z. And when we do that, this new integral gets transformed over to a new triple integral, and our region is the same region, right? But it's just represented with a different coordinate system. So I'll just call this S. And now we change x to r cosine theta, y to r sine theta. Z will remain z. And then very important, because we're making this conversion, we have to put r, and then it's going to be something like dz, dr, d theta. And the order here may change, but we have to insert that r because of the conversion. Today, what we're going to do is do a new type of coordinate system, spherical coordinates, and the conversion there is going to be different than this conversion. All right, so let's talk about not only what that conversion is, but let's talk about the spherical coordinate system in general first. So for spherical coordinates, if we're going to convert from Cartesian to spherical, we're going to let x be replaced with rho cosine theta sine phi. Now, some people pronounce this phi, some people pronounce it phi. You might hear me saying both. Rho is like r, like the radius. So this is like we had r cosine theta back for cylindrical. Well, for spherical, it's going to be, we use rho instead of r. Rho cosine theta sine phi. Y is going to be rho sine theta sine phi. Z is going to be equal to rho cosine phi. And then we have an identity here that phi squared equals x squared plus y squared plus z squared. So what does this coordinate system look like? Let me get back to my initial settings here. All right, so imagine that you have the XYZ plane, or sorry, the XYZ three-dimensional space. And imagine that you are, standing at the origin and you're looking straight up the z-axis. And you're pointing, you're orienting yourself where you're not only looking up the z, but you're kind of facing, if you look straight down, you'll be facing the x-axis. So here's the x-axis, here's the y-axis, here's the z-axis. So you're looking straight up. And then we want to get to some point that's out in three-dimensional space. So I'm looking up, here's the x-axis. I'm going to rotate my head down. The angle that I make between myself and the z-axis, that's going to be phi. So I start to rotate out, and you can hopefully see, if I rotate this, I am, I'm kind of parallel to the x-axis here. So I rotate out a certain angle, okay, from the z-axis, that's going to be phi. And then, once I've rotated out, I'm trying to get to some point, I'm going to now, here's the x-axis down here, I'm going to rotate myself this way at some angle, and that angle is going to be theta. So let me rotate this. So notice that what's going to happen, I'm going to start swinging out this way. Okay, that angle here between the x-axis and the ground there is going to be theta. And then rho is how far I go out. So rho is the distance to that point. So I can decrease this. Let me try and zoom in, see if you can see this a little better. It might be a little bit easier to see there. Come at it from this side. So there's my phi changing, and then there's my theta changing. So if you can imagine right now, if I just take this point, okay, so remember rho is the distance from the origin to the point. If I just take this point and I start letting theta change and make theta go from 0 to 2 pi, then what's going to happen is I'm going to swing all the way around. Okay, I'm going to swing all the way around. Are you subbing? Okay. All right, I've got to stop this video.